Okay, so now that, today we're continuing our talk about sine and cosine graphs. Now that we know the main sine and cosine waves, now we're going to add vertical and horizontal or phase shifts. But the good news is that you have already done a lot of work with shifting graphs, right? We know how to move a graph up or down or left or right. We know when we add a number to the outside of an equation that always moves our graph up, right? And now we're going to add a technical term for moving up, calling it a vertical shift. That makes sense, right? If we subtract a number on the outside, we have already learned that this moves our graph down, another kind of vertical shift. When we add a number to the inside of a graph, we have already mastered that moves our graph left, and we call this a horizontal shift or a phase shift. And then you guessed it, when we subtract a number from the inside, that's going to move our graph right, another kind of phase shift. So what we're going to do is take our main wave, sine, cosine, and we're going to do some up, down, left, right movements with them. So I always like to label my x-axis. I can tell right away that just because it's plain sine x, that I'm not changing the period at all. So I can go with my standard tick marks, pi over 2, pi, 3 pi over 2, and 2 pi. Sometimes I like to just, dot in the regular sine wave. That's not my answer, but that's the regular sine wave. And now I'm going to shift, it looks like, down 1. Do you agree? So basically I'm going to take every ordered pair that's in the regular sine wave and move it down 1. Take this 1 and move it down 1. This one and move it down 1. This negative 1 comes down 1, so now I'm at negative 2, and then the 0 comes down 1. So my answer wave is just this. And I'm just going to have you graph one period or one cycle of it, so that's it. Down 1. Good to go. Getting a little bit trickier here. Now I'm adding and subtracting on the inside, so we know that this is going to go right pi. Right pi. So I'm going to start off with my same tick marks, pi over 2, pi, 3 pi over 2, 2 pi, 1, and negative 1. And like I did before, I might just dot in the regular sine wave. And when I think about going right pi, since I'm counting by pi over 2s, I'm going to go what I call 2 clicks to the right. So I'm going to take this and go right 2. And this ordered pair here, right 2. 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 Now here's the thing, I have to label these new tick marks. So I have to realize I was just counting by 1/2. 1/2, 1, 1.5, 2, 2.5, which would be 5 pi over 2, and then 3 pi. And so here's the sine wave moved right pi. You're like, well, it's not that hard, right? So you know it's going to get a little harder at least. Here's our combo move. So this one here is telling me left pi over 2 and then up 2. So again, I'll start with my basic tick marks, pi over 2 pi, 3 pi over 2, 2 pi. Starting with my 1 and negative 1. Here's my sine wave. And this is optional, by the way, to dot in the sine wave, but I find it helpful. So now I'm going to take every ordered pair, left pi over 2, might as well label it, and then up 2. So up 2. So left here, 1 click, and then up 2 clicks. Here, if I'm at pi over 2, 1, left 1, 2, so this is going to get kind of high up here. And once you get going, you're kind of good. 1, 2. Here, I was down here, left 1, up 2, and here I was here, left 1, up 2. So the only thing I really needed to label tick mark wise was that negative pi over 2. Now sometimes people like to draw like a little dotted, what we call the midline sometimes, or sometimes I call it like the new, quote, new x-axis if you're shifting it up 2. That's optional, but you could certainly do that. Oh, now I'm looking. I forgot to shift in the amplitude and the period. The amplitude and period actually is not changing because I'm just taking my graph and picking it up and moving it left or right or up or down. So I'm going to have an amplitude of 1 and a period of 2 pi for each graph. So there's the down one, there's the right pi, there's the left pi over 2, and up 2. All right, so now we just do it with the cosine wave. So now we're going to take the cosine wave here. We're going to go up 1. I'll fill that in right away. Amplitude 1, period 2 pi, right? Pi over 2, pi, 3 pi over 2, 2 pi. Again, I might dot in the original cosine wave, just kind of lightly in here, not perfect. And now if I take that and go up 1, I'm going to come up here to 0, 2. This is going to come up to 0, 1. This is going to come up to 0. This is going to come up to 1. And then this one here would come up to 2. And again, I know that it waves. It's not a V, but it's a continuous wave. So there's the cosine graph moved up 1. Here, it's a shift again of left pi over 2. Left pi over 2. So again, and it's not going to affect my amplitude, my period. So right off the bat, I could say my amplitude's still going to be 1, my period's still going to be 2 pi. All I'm doing is moving this back pi over 2. So you can see that, you're going to get really good at these pretty quick. There's the cosine wave. If I move it left pi over 2, so here at negative pi over 2, here, 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 here. Still has an amplitude of 1, still has a period of 2 pi. And then you probably saw it coming, the combo shift, right? Combo shift here is left pi, up 1. Left pi, up 1. So this is going to be left kind of 2 clicks. So pi, every tick mark is 1/2 pi. So if I go left, I'm going to have to go negative pi over 2 and then negative pi. And there's my 1 and my negative 1. Amplitude is still going to be 1. Period is still going to be 2 pi. Here's kind of the old parent graph. And then taking each one and clicking it left 2, up 1. Right? So now it's going to go to 2. So here, left 2, up 1. Here, left 2, up 1. Here, left 2, up 1. Yeah. And then here, left 2, up 1. I feel like I'm getting a little sloppy here. You want to keep it as neat as possible. It's not terrible though, right? So there we go, left pi, up 1. Then we just have like some differences. So now we're starting to put things together, like what's different between 3 sine 2 theta and 3 sine theta over 2. So hopefully you can notice there's a difference in the periods of those graphs. So this first graph has a period of pi, and I'm just using my formula 2 pi over b. And the b here is 1/2, where this one's, it's a pi, and this one has a period of 4 pi. So that's the difference. Period of pi versus period of 4 pi. You don't have to graph them, just have to say the difference. Explain the difference between these two graphs. Well, this one looks like it goes down 1, and this one looks like it goes left 1. Which, by the way, I usually don't have you graph one like that where it's left 1. It would be like left pi or left pi over 2. But just to show the difference that subtracting on the outside versus adding on the inside. Now we're going to go back and write an equation. This is a little bit tricky because it's got kind of everything going on. Let's see. The sine wave, let's see, the amplitude is 3, so that would be sine. The period is pi, so it's 2 pi, or 2x, I should say. So that kind of like encapsulates those things. But then I got to do the left pi over 2 and the 3 up. So I guess my final answer, if I can write it here, is 3 sine 2x. Left pi over 2 is going to be plus pi over 2. And then up 3. So left pi over 2, up 3. cosine equation here, amplitude of 10, so this is 10 cos. The period is 4 pi, so that gives me that 1/2. I can just do this all at once. Right pi, so minus pi, and then 2 down, minus 2. Ta-da! Amplitude 10, period 4 pi, right pi, down 2. So this is taking sine and cosine waves and moving them left and right, up and down, and then just kind of pulling it all together at the end.